So you must have heard about the Colossal Biosciences direwolf news about them claiming to have created direwolves.
Yeah.
Yeah, so I think so you can view the screen.
Mm-hmm.
Okay, so I want to talk about this news and also a bit of the science behind whatever the process they have gone through, whatever the process that they did. So as per the news, this is what they did: that they have extracted the DNA from two direwolf fossils. So as we know that direwolves have been extinct for over 12 to 15,000 years.
Mm-hmm.
So what they did is that they extracted this DNA from these two direwolves from a 13,000 year tooth and a 72,000-year-old skull. So that's where they got the DNA from. And
Okay.
then what they did, okay, so what they did next was that they sequenced this DNA to find the variants. Uh, so what they did was that they compared this DNA that they are recovered from these fossils with the DNA of a what was that, a gray wolf. So they compared it with a gray wolf. Why gray wolf? Because as per them, gray wolves are the nearest uh, relatives, genetically speaking. They are the nearest relatives to dire wolves. So what they did was they did a side-by-side comparison of a gray wolf's DNA with the dire wolf's DNA, and they saw what differences are there between these two animals. And then what they did was that they made the necessary changes in the gray wolf's DNA using CRISPR technology. So it's like editing a computer program. Suppose I want a computer program to run, not a program. Suppose I have a set of code and I want it to run a certain program. Suppose I wanted to develop a game, but I don't have the original code of that game. But I have another code for a game which looks very similar to that. Okay, so what I did was that, okay, maybe I do have the original code, but I don't have the actual game. Okay, so what I did was that I took the code of the original game and compared with the code of the game that I already have, and I saw so most of the things will be same, but there will be certain areas in the code where there will be some differences. So what I'll do is that in my own code, in the code of my own game, I will edit those parts out and put those parts from the original game. So so technically they did the same thing in terms of DNA. So that was that was the core science behind it in terms of the engineering aspects. And so at the end, what happened was they created these wolves, which they claim to be, which looks to be physically larger than normal wolves. So that's what they claim to be. But again, there are experts who say that it's not actually their wolves and so on. So there are still some debate going on this matter. So I have a bit more of the science behind this that I want to talk about. But before that, do you have anything to say?
So I was thinking that maybe this technology is only possible when a close relative of whatever they are trying to recreate is existing. Like they will not be able to completely create or de-extinct something that has no close relatives left.
Yes, because yeah, I think so. That's true. Because what I understand is that the technology how it works is that there should be, so as I mentioned, they edit the DNA of an animal that already exists. So okay, through the DNA they may get the actual code, but it's so if I give the analogy of a computer, it's that suppose I have a program of a certain, I have the code of a certain, again going back to the game analogy. So for example, I have a code of a certain game, but that game runs on a certain kind of hardware which is very old, which no longer exists. Suppose it doesn't run on an advanced laptop, it only runs on old video game consoles. So I might have the code, but I can't run that code on this on a new hardware. So that's the same thing with the DNA. Is that they might retrieve the DNA, but they can't run that DNA because they don't have the hardware. They don't have living organisms. They don't have the actual organisms that contain the DNA. So what they do is that they find someone, an animal which is as close as possible genetically speaking, and they edit the DNA of these closest animals. So that's how they do. So yeah, the closer they, so I think that the closer these animals are genetically, the more likely that they will be similar to the original animal. So yeah, that's what I think.
Yeah.
Okay. So I thought of speaking a little bit about the basics of DNA and so on, because uh, I think it would be much more helpful for someone to understand the science behind this technology. So do you know about? Have you heard about DNA, genome, genes?
Well, I know in general like what they mean, but no, nothing specific.
Okay, so I want to just clarify or make some connections between these concepts. Okay, so here I have this chat where you might be able to understand quite a bit. So there are a few terms that I want to talk about. So this, can you see this line here?
Mm.
Okay, so what we have is this thing. So when you say about the DNA, you may recall this structure. You might have seen this structure somewhere.
Yeah.
Yeah, so this is the DNA. So what does the DNA contain? So you can think of the DNA as the hardware that contains all the information, contains the code. Think of it as, literally think of it as a hard drive that contains the code. And this code is known as the genome. Okay, so if you can see here, this set of patterns is CATG, CATG. So think of this as just like computers are binary, there are zeros and one. Think of DNA as same, but instead of binary, it has four bases: A, T, C, and G. So instead of 0 and 1, it has A, T, C, and G. So DNA contains the whole sequence of information, and this sequence of information is called as genome. That is that is what this is, genome.
Mm-hmm.
So for each animal, the genome would be different. Just like for every software, its program is different. So it has different capabilities, different things that it can do. Okay, a web browser can't do certain things which a different application can do, and so on. Now we come to the fundamental part, which is called as the nucleotide base. Again, if you go to this diagram, now this is a very abstract one. This is what we can call it as a logical diagram. For example, you might remember in electronics we have logic gates. So there are different diagrams for logic gates, for AND gate, for OR gate. Do you remember those things?
Yeah.
Yeah, so those are so supposed to distinguish an OR gate and an AND gate. With the arrows, the symbols are different, but that is just symbolic to understand. The actual in physically, it doesn't look like that. For example, if I show you AND gate, so yeah, suppose this is the logical diagram of a AND gate. For OR gate, it's something else, but it's just a representation. The actual AND gate, when it is physically implemented, doesn't look like a semicircle. It looks different. So in the same way here, this is just a logical representation. So what it actually is that for each of this alphabet in here, A, T, C, and G, these are organic chemicals here, as you can see here. So this is what it is. So these are the nucleotide bases here. And now what happens is that it's now you don't have to think about nucleotide bases anymore. Now you have to think in terms of three, in groups of three. So suppose let's start from here. We have C, C, and A, C, T, and G. So each three nucleotide bases. So for clarity, each of these alphabets are called nucleotide bases, as this diagram says. So each three of those nucleotide bases codes for a certain amino acid. And okay. Oh, were you about to say something?
No.
Okay. So each three amino acids contain code for a certain amino acid. Each three nucleotide base. And let's suppose this is one small strand, one small section of this whole DNA. So this small ladder-shaped thing is one small section of the whole genome. So this one small section is called a gene. Okay, and one gene might contain a lot of these three pairs of nucleotide bases. And for simplicity, these three pairs are called as codons. It's called codon because it codes for a specific amino acid. Sorry, yes, exactly, amino acids. Okay, now if you come back to here, these three sentences will help you make it clear. So a nucleotide base is a single block of DNA. The single building block A, T, C, and G is the nucleotide bases. And a codon is a sequence of three nucleotide bases. For example, A, T, G, C, G, A, and so on, that codes for a single amino acid. And a gene is a long sequence of codons. It means it's a sequence of multiple three groups of nucleotide bases. And it codes for a specific protein. And proteins are everything. So for the common people, we think that protein is for muscle building and so on. But in practicality, everything that goes on in not just a human body, in any biological life form, it's all done through proteins. Nothing else is there. Proteins are everything. So it's like, suppose if something has to be done, so what happens is that, and previously I was talking about amino acids. So amino acids are the building blocks of proteins. So a certain amino acids, certain set of sequence of amino acids are grouped together to form a protein, and so on. And as you can see here, amino acids forms proteins, and protein forms everything. And as you can see, there are different use cases of proteins here. They help do everything here. So this is what the science behind everything here it is. Now what they have done is that, as I've said, CRISPR. So suppose if you want to for example, as I said, the code base of different animals is different. So, and this code base is what is used to create the actual thing. So for example, a direwolf's code base is certain things that makes it a direwolf, and not a, what was it, brown wolf or whatever, what was that thing?
Grey wolf.
Grey wolf, yes. Brown wolf, okay. It was a gray wolf. So what differentiates a gray wolf from a brown wolf? Okay, it's not a brown wolf; it's a dire wolf. So what's different? What differentiates a gray wolf from a dire wolf? It's that its base pairs, these codons, are different. So it's programmed so that DNA of a gray wolf doesn't have certain genes that codes for certain proteins, which then creates certain physical features. So what they did was that they edited out. Suppose I want to remove this T, C, and A and replace it with something else, so that it creates a different protein. So this is how they edit this out. Suppose they'll cut it from A and T here. They'll remove this and put some other three pair. Put another code on here. So this will code for a specific feature for their animal. So that is what is going to differentiate a gray wolf from a dire wolf. That is how they created. They included the code from the DNA that they've extracted from these fossils into the gray wolf's DNA. So that's how they did this. So yeah. So do you have to say anything else about this thing? About this?
No.
Okay. So yeah. So what's next? What else do you want to say about?
Is that all from you?
Yeah, about this direwolf news. That's all from me.
Then should we move to some different topic then?
Yeah.
Maybe I don't have any big topic but one small point was regarding Devin. So you must have heard of Devin, right? Which was
Yes. Yeah.
it was launched as a coding assistant, and there was a lot of hype around it when it was announced,
Yes.
saying that it was going to be it was going to replace developers and stuff,
Yeah.
basically. But and that was the only time I heard about it, and
Okay.
then it kind of faded in the background or everything. But
Yeah.
recently I saw a news that there is a major price drop in their model. So they were initially charging $500 per month,
Okay.
and they brought it down to $20 per month now.
Okay.
So like that is one interesting. I found that point interesting because like the hype, I don't think they were able to deliver on the hype or everything, because similar other uh, IDs came up where you like basically like similar to Copilot, GitHub Copilot.
Okay.
There's one that I know of. It's called Cursor.
Mm.
So it has all the AIs inbuilt. So nothing major to talk about. Just one this point. Then one, I think a little bit of a bigger news is regarding this tool or model called AI Scientist version 2.
Okay.
So I think this is by some company or group or called Sakana AI. So they had initially the AI Scientist, and this is the version 2. I think this version model was used to create or generate a completely uh, unassisted scientific paper from start to finish. It was completely AI, and it is a peer-reviewed scientific paper now, I think.
Okay.
So I don't know the details of what the paper is about and what the novelty is, if there is any novelty in the paper or not. But I just saw the news. Maybe you can do a little bit of Google and search
Yeah.
AI Scientist version 2. First
A,
AI Scientist.
I actually looked into this company back in February a bit. So yeah, as you can see. But this is their old one.
Check for the news.
Yeah, it's in their blog. It should be, because I remember going through their blog. Okay, it's not in the blog. Okay.
Just go to the news tab.
Yeah, scientists too.
Is there no new? Let me see.
Is this AI first AI peer-reviewed paper?
Wait a second.
On 17 March, Japan-based tech startup creates first AI peer-reviewed paper.
Maybe.
Yeah, this is its AI program AI Scientist V2 successfully passed the peer review process and the paper was accepted at a workshop. Okay, it says the AI paper underwent the same review process as human submissions.
So they're not telling about what the paper is about, or will it be below?
No, there is no.
Maybe you can ask Copilot or something regarding this page.
Where is Copilot? This.
Yeah.
What should I ask?
What was the paper about that Sakana AI scientist version 2 release something like that? So they wrote a paper about themselves.
It seems. I don't think this. It wrote a paper about how it did a research. It's so. It's perpetual, like an infinite loop. Okay, this is the paper. AI scientists V to workshop level automated scientific discovery via agentic research. So it wrote a research paper how it does research. It sounds very loopy.
And it seems it had knowledge about itself or maybe how it works, so it was able to write it. But something completely novel, I don't know if that is possible.
No. I don't think this is the paper that the scientist wrote. This is the paper about this code, this research, because it was written by this
Yeah,
researcher.
yeah.
So this is how this is what they say. We introduced the AI scientist V2 and end to end so on and so on.
So what paper did AI scientist wrote? Can you ask it like that?
Home to Copilot or to some.
Yeah, maybe Copilot only. What did it write below that? We did not read completely, right?
Let me just search it in Google directly. This is from their official blog. So a paper produced by the okay.
So there's no link or anything to the paper actually, or is it
No,
this one?
I think with is it this? Yeah, the AI scientist V2, after being given a broad topic to conduct research on, generated a paper titled "Compositional Regularization: Unexpected Obstacles in Enhancing Neural Network Generalization." So this is the paper that this AI wrote.
Mm.
So yeah, if someone wants to look into it, they can search this heading and they might get more about this.
Yeah.
Okay.
So there is nothing more to it. Just this piece of news.
Okay. Okay. So let's look at something else. Let me look at this one, Scout AI. This thing was released today itself. The I mean, the startup was there for a while, but it was in stealth. By stealth, I mean there are startups that are in stealth, which means that the public doesn't know about it yet. They haven't
Mm.
revealed
Yeah.
themselves. Okay, so today is the first time that they have revealed themselves, and I found it very randomly on Twitter today. Actually, not quite so random because I was looking through the account of Figure AI's CEO. You might recall about we looked
Yeah.
into Figure's demonstrations a few times. So its CEO, he does a weekly tweet that where he summarizes a lot of AI news and so on. And as I was looking through his tweet, I found that this company was actually created by his brother.
Mm.
So that is how he retweeted about it, and that is how I found out about this thing. So again, this is also a vision language action model, just like the one we talked about with Figure AI itself, and also Gemini Robotics, the video we saw that one too.
Yeah.
So those are again vision language action models, but this is specifically tuned for defense related purposes. So again, let's look at this video. So okay, first of all, this is the website. We'll come to it, but I think so we should look at the video first. The thing is that it's just released a few moments ago, 10 hours ago, only 10 subscribers, one video. So it's brand new.
So it is only for defense purposes, and it's not any open source or anything like that.
No, not at all open source. And this, I don't think this is ever going to be open sourced. This is for very specific purposes. And when I look at this, and there's this group of companies that I say which are very much focused on defense. And by looking at these companies, other companies that I'm talking about are Anduril, Palantir, and now this. But when I look at these companies and the and the capabilities of these companies, it seems to me like that US is quite ahead in terms of their technology, defense wise. So of course there are nuclear weapons and so on, but in terms of this kind of tactical weapons, technological advancements, they're quite ahead. So let me just look at into their websites. So this is, even I'm looking at this website for the first time because, as I've said, they've just released it hours ago. So let us just look at what it is about. Robot to robot communication via natural language for swarm coordination. Swarm coordination. So it almost seems like that there will be a central intelligence that might be connected to all of this and managing all of those things. And again, they have said this is a vision language action model and so on. Okay, here they have mentioned about what are the inputs and outputs. So input, there is real-time camera data and real-time text and audio prompts that will go into this LLM, and output for land that which will be, so essentially this is a self-driving mechanism, again for air, the equivalent of self-driving for air and sea as well. So this is what they call their foundation model, Fury. Okay, so there are two different variants of this model. This G01, which is an unmanned ground vehicle with physical AI. So it can control ground vehicles, whereas A01 can unmanned UAV, so it can anything which is aerial in nature. But they haven't launched it yet. It is coming soon, but G01 is probably available. Yeah. Okay. So A01 is not available. So here they go into more details and so on. Yeah. I'll read it more in my own time. Okay. So yes, after looking at this, I had this idea about researching more about this defense tech companies and so on. So how does this whole ecosystem work? Because I've already seen Anduril and all their products and services, and now there's this one. So in some ways, it does seem that there are certain products look similar, but I think they might have to have some ecosystem where one product integrates into something else, someone else, to someone else's product and so on. So yes, I don't know anything about it right now, so I think I'll have to look more into this to give a more detailed opinion about this thing.
And their only sole customer is the US military then.
Yes, it's written here. Yeah, for the US military. Yeah, that's their only customer here. So which means that would be
So
the
then it
case.
must be subsidized as well. or
Yeah,
they're completely private, and I mean they will be private but without any support from the military.
I mean they will probably get some assistance. So yes, I have to really look into this. How defense tech companies work in general. So how much influence and role they have. I mean, it has really sparked my curiosity about defense tech as a whole.
Because like other private companies, you cannot even advertise it, and you know your customer is only one organization,
Yeah,
so they have to accept whatever you're building,
yeah.
so you have to build specifically for them.
Hmm. So yeah, I have to really look into this. So which also makes me think, how does a company like who are Anduril's customers? Because Anduril is another company who is only into defense tech. Primarily serves as supply to U.S. Department of Defense and Homeland, U.S. Department. Okay, different security and defense departments within US, as well as Australian Defence Force and the UK Ministry of Defence. So it does for Anduril. So they do have customers from other countries too. Let me look at. Okay, this is Palantir is more much of it's a more broader company, but but most of its a lot of its products are used for defense purposes too. I'll get into it later on. Let's go into something else now. So one thing I want to talk about is about Runway ML. So I think so on 31st March they released their generation 4 model, and one thing I think the key highlight of this new model is that they have this significantly improved character consistency. And why is character consistency important? It's because if you want to use AI to create movies, I mean long form movies more than 5 to 10 seconds, what you have to do is what it must do is that it must have characters and scenarios that must remain consistent throughout. So you can't have one person in a single scene and a different person in a different scene. So it must have maintain the same characters, means same physical characteristics throughout the whole video, and the video will consist of different clips. So multiple clips must have to have this consistency over time. So this is what they claim that they need this generation 4 models have this potential. Yeah, I think so. This statement here, this will make it clear why consistency is important. So this consistency breakthrough is critical for enabling longer form narrative content with continuity, a key step toward Hollywood level production quality. Why?
But
Yeah.
why are they using Hollywood level production quality? I mean, is it really that good now?
Okay, I'll show you. It's not that good in terms of length. It's not, no, not even close. It's, I think it's still 5 to 10 seconds, but quality wise, I'll show you. There are some demos here. Okay, this demo. So what do you think?
It's good, but I still don't think her face was 100% consistent. Like there was some variability there.
Yeah, I think so. Yeah, it is, but it's more or less means for me it was quite difficult to figure out the differences. But so more or less it looked quite
It
similar.
was very similar, more like 90% similar, but like
Yeah.
few differences I could see.
Okay. So I think so that is why they have said that it has made improvements. But yeah, I think so. Probably because I haven't followed this part of AI about video generation in AI, so I do not know. But I think that the previous generation of models they did not have this capability at all. So probably if you create one video clip and when you create a second video clip, it couldn't maintain any consistency between clips. So maybe they have made some progress here. So let's look at a few more if it's possible. Get every angle of a scene.
So this person that has they have created, so it's does not. I mean, it does look like other people, but it's not any
Specific
inspired by
person.
any one specific person.
No, it's not inspired by any specific person. It's just is.
But ultimately, will look like that. So there will be someone in reality who looks very close to that person.
Yeah, maybe. But
So is there a possibility of like maybe there's some lawsuits or something because of the people can sue them, right, for resemblance of likeness or whatever that's called.
yes, I'm. But yeah, I think so. The laws have to be rewritten because in general scenario, because you see that already they have this disclaimer in front of most movies and series that it's purely work of fiction, and if it's any resemblance is pure coincidence to avoid any such kind of things. But if it's AI, so how can they how can they do this? So if suppose I think that I remember back in during my first semester of MBA, there was this subject called legal aspects of business. So the teacher was talking about how difficult it is to determine what is copying and what is inspiration. So he was talking about a book that a person wrote a book and then some other person created a movie or wrote another book, and this first person he told that no, your movie or looks quite similar to the story that I wrote in my book, and then this person he told that no, it's not similar, I read your book and I was inspired by it, but it's not similar, and so on. So it was a very difficult one. So where does this line exist between copying and being inspired? Because in most cases people everyone has their inspirations, that nobody just creates things out of vacuum. If suppose someone never saw a movie, how would they know that there exists a thing called movies, and how would they create styles? Because again, especially in form of art, in art forms like painting or movie making, there are people who make connections that okay, I was inspired by this director and his filming style, and that is why I make my movies, and there is some resemblance. But at what point, what is the line that differentiates inspiration and resembling and direct copying? So that's for general purposes I'm talking about. But when it comes to AI, I don't know how would they determine this thing.
Mhm.
So yeah, So yeah, in this there are many more videos here. You can see a collection of short films and music videos made entirely with this model. So there are lot more videos here. Let me look at this. Alright, that was about Runway. And finally, a little bit about Llama 4. So these are. So how long was it? When did they release Llama 4? I think so. It's probably been a week.
Yeah, something like that. Yeah.
Yeah. So I wanted to know. So what are the upgrades in Llama 4 compared to Llama 3? So these are the four main upgrades that I found. So I'll come to the first one later on. So let me cover the last three first. So yeah, it uses this mixture of experts architecture. So which Llama 3 didn't have. So yeah, the basic idea of mixture of experts is that there are different experts for certain topics. And if a topic falls into a certain criteria, only that part is activated or used. So in that sense, it says that it makes it much more efficient and more scalable than Llama 3, and much more it has better performance. So mixture experts is something new in Llama 4 which didn't exist in Llama 3. Okay, and that also talk about the larger context window. But you talked about this that this it's not actually true.
I mean, I don't know if it's actually true or not, but
Okay.
people are complaining that it's. I don't know what even the exact complaint is, but it basically loses context after much lower than the context window they have mentioned in some cases at least.
Okay, so this is what they said that Llama 4 supports a context window of up to 10 million tokens compared
Yeah.
to Llama 3's 128,000 tokens. So on paper, at least on theory, it is a huge upgrade, more than 10 times. I mean, it's quite a lot. But yeah, in practicality, how much is it possible? I don't know. And the next thing is multilingual training. Okay, so this is something that Llama 3 didn't have. So it says that Llama 4 is trained in 200 languages, over 100 languages having more than 1 billion tokens. Okay, it is 10 times more multilingual than Llama 3. So which means that Llama 3 was trained in 20 languages. Okay, so in terms of multilinguality, it's it's a significant improvement over Llama 3. Now coming to this thing. So it took me a while to understand this part. That native multimodality with early fusion. So what I understood was that the process. So before this, I didn't knew about this thing. So it says that it can process text, image, and videos together. So what it means is that so I was so let me just okay, let me just try to explain it myself first, then I'll show the actual source. So normally what happens is that when you for normal multimodal models, so it processes each format separately and then outputs a result. But here what it does is that it so Through in the pre-processing phase, it converts the input into the desired format in which the large language model accepts. So it does all the pre-processing together and then it sends it to the large language model together, not separately. So it's a bit technical. I had to look more into it. So let me show you this thing. Yeah, so tell me more about this early fusion. So here it says that uh, early fusion is a strategy in multimodal machine learning where information from different modalities is combined at the very beginning of the model's processing pipeline. This means that the features extracted from each modality are merged into a single unified representation before being fed into the core of the model for further learning and prediction. Okay, so I thought that this is how multimodal models worked, but apparently it doesn't. So probably in general multimodal models, so the text is processed differently, pre-processed differently, and inputted differently, and so on and so forth for the various models. But as is mentioned here, it's all merged into a single unified input before giving it to the LLM. So this is the main idea behind uh, early fusion technology. So I didn't know about this until today. So yeah, this is something new I learned today. So do you have anything to say on this?
No, not really.
Okay. So yeah, so that's about it for today.